Good day guys, welcome to Builders on Academic Tutorial, and today we'll be considering Waec chemistry practical and specifically the likely questions for 2021 Waec qualitative words, and I see that the likely questions that you might meet based on the words on the reagents given on the sample given to us as regards qualitative analysis, and the reagent given to us in the sample C is a mixture of two salts. Now they carry out the following exercise on C. Record the observation and identify any gases evolved. State the conclusion you draw from the result of each test. Now the first question now, it says that C will be a mixture of what? Of two or the first instruction here is that C is a mixture of what? Of two salts. And then we should record any gases that is what is being evolved along the way, and what we should be able to draw conclusion from all our results. Now the first thing you have to do here is to put C in a test tube and add about 10 centimeter cube of distilled water. Now I want to explain the practicality, the practical aspect of this work in just few minutes, and it's going to be able to have the understanding of what the practical is going to look like, so that we'll be able to have a good a table of what analysis, and we're going to have a good record of analysis. Now the first thing is that C, as we all know, that is a mixture of two, a mixture of copper sulfate and ammonium carbonate. The mixture of two. So the sample C that we call to be the mixture of copper sulfate and ammonium carbonate. And when you add water to this water, though the copper sulfate and the ammonium carbonate are individually they are soluble in water. Individually, these two salts are soluble in water. But when you mix the two together and then add distilled water to it, the reaction is going to take place, and there will be exchange of radicals. And new compounds will be formed. New salts will be formed. Which one of which will be soluble, and the other will be insoluble. And a reaction the chemical reactions that will take place when you have what? NH, when you have what? So copper sulfate with what? Ammonium carbonates together. What we are going to have in rather of distilled water, we are going to have copper carbonate being formed plus what? Ammonium sulfate. You can see the radicals as exchanged, as well as change their position. Now carbonate is now with what? The carbonate is now with copper, and sulfate is now with what? Now with ammonium. Now initially they are both soluble, but now this will form a residue which is insoluble. To form a residue which is insoluble residue, a green residue, or a bleach residue which is insoluble. Why this one will form blue precipitate, blue filtrate, which is what? All it's a soluble aspect of the word of the sample. Now, and what we are going to have in your test tube when you have add your what? Because the question says, the first question says, add what? Put all your sample in a test tube and then add the water. You add water to it. For that. Okay, let's just have a diagram of what it looks like. So we have what? So when you have your funnel, you bring in your funnel here. Bring in your funnel and your filter paper. On this filter paper, you are going to have a green residue. Mind you that a green residue which is what? Carbonate. And I want to have a blue what? A blue filtrate. A blue filtrate, which is what? A blue filtrate, which is ammonium what? Ammonium sulfate. Now, after you've added your water into your sample, you shake thoroughly. Then you allow for a while, then you now filter. You shake thoroughly and you filter. You're going to have a copper carbonate and ammonium sulfate. The copper carbonate is still on the filter by your residue, and the good filtrate will come down to pass through the filter. Now, how do you record your analysis? And this is how you are going to record the table of analysis. And following, you have to record your table of analysis neatly and correctly from systematically. Let's do the table of analysis. Yeah. Let's have the column for serial number, because it's very, very important. You need to arrange your words, because those questions are systematically what. So you must have a consistent arrangement of what serial number. And we have what there is what we have the test column. This one is what the observation column, and this one is your inference. What we have from what observation. Now, the first question says put a C, that is, you call this 2A, that's 2A. Ensure you put your number there, 2A, C plus distilled water, C plus distilled water, then shake thoroughly, then filter. Now, see, what do you see? As you can see from the top, you can see a greenish residue, or green residue, and blue filtrates. Observe. Green residue and blue filtrates were observed. Now, what will be your conclusion or your inference here? It will be what? C is a mixture of soluble salt. It's a mixture of soluble and insoluble. Salt. As you can see, that is a mixture of soluble and insoluble salt. So that's that about 2A. You now say keep both the filtrate and the residue. Keep both the filtrate and the residue. And then you now say the question B now says 2B. Right, these are 2B. Divide the residue into two portions. You might be asked to divide the residue into two portions. Please, you might have to what? You have to take the filter paper and use your spatula to divide the residue into two test tubes. Your residue was divided into two test tubes, which is this is the first portion of the residue, which is copper carbonate here. So just the residue there. Now, to that, to divide the residue into two portions, then perform the following experiment. What I will ask you to perform: heat the portion of residue strongly in a test tube. Now, it means that the first portion of the water, which is 2BI, this is 2BI. He said the first portion of the residue, plus heat, first portion of the residue plus what? Plus heat. What do you observe? Now, what you observe is that this greenish residue, the color change to what? To black. So the color of the residue, the color change The color changed from what? From green to what? To black. What? Black powder, as you strongly what? Eat. The color changed from green to black with evolution of gas. Now, evolution of gas. Now, the cream residue here, when you eat it, when you strongly eat it, apply strong heat to it, the color change from green to black powder with evolution of gas. Why is this necessary? Because you know we are having copper what? Carbonate here as a green residue. So when you eat it, there is an oxidation that takes place. That is, the copper is being oxidized. A reaction takes place. Nobody will ask you about the reaction, but when you eat it, the composition takes place. CO3. What? We form what? CO2 plus what? CuO. That is, this salt decomposed to give you what? To give off this gas. To give off this gas. This gas is what? Is given off. This is left behind, which will give you black what? Black color. So the evolution of gas here is what? Is CO2. So the possibility that we have what? CO2 presence. CO2 gas presence. But you might not write anything here. Just they might ask you, the reason why I consider that they might ask you, it might be one of the questions in what? In the exam. So CO2 presence, CO2 gas present. But so evolution of CO2 gas presence. This is one of the characteristics of copper. Of copper 2 carbonate. Now let's move on. So, but it has not been confirmed. So we now move to the second portion of the question. You do ask that I say add hydrochloric what? Dilute hydrochloric to the second portion of the recipe. So let's read this one. Mind you, this might just be one of the section, but it might not be what. If you don't see it, no problem, but others might find it there. So the second portion of the residue plus dilute what? HCl. You dilute what? HCl. Now be careful. Now these are things you have to observe very well. You add what? When you add what? When you add dilute HCl to the what? To the residue. To second to this was dilute HCl. The first one is what? Dilute what? This one. Adding what? Dilute HCl to it. Dilute HCl to it. There's something that will occur. Effervescence will occur. Effervescence means a bubble. There will be effervescence. Effervescence occur. When I say effervescence, a bubble will occur. Like a bubble will occur. And a colorless bubble will occur. And a colorless, odorless gas. A colorless, odorless gas. Which tone lime water milky was given up? Which tone lime water milky was given up? This is what we're going to observe. Now, when second question, when you add dilute what? HCl to it, effervescence will occur. There's a bubble. We see a bubble inside the space. A bubble, something like a bubble here. Then, which indicate an evolution of the gas. That gas is what? Is colorless, odorless. Which tone lime water milky? Which tone lime water milky is given up? So this is a confirmatory test of what? See that gas is what? Gas here that will upload, which is a confirmatory chance of the gas we have in the world. The first thing for the first column, gas is CO2 from what? From CO3 minus, that is from what? From carbonate ion or hydrogen carbonate. This you can put this on there so that you have your moment. So we have what? This column being taken care of. Now, if you have any other questions, please you can drop it in the comment So you have, so now the next thing is what? Add what? And now we have done this to BI. Now to the solution of what? Of it. Now that's why I said you should arrange the what systematically ordered. So now to the solution in BI now. So we are going to obtain a solution here. A solution here. Evaluation protocol. We are going to obtain a solution from it. So to this solution that we obtain from it. Now that solution, what are we supposed to do? Add sodium hydroxide in drops. And then in what? In excess. So 2C says that 2C says that the solution in what? The solution obtained from what? 2BII. Solution of to what? Solution obtained BII. Add what? Solution what? 2BII plus what? Plus sodium equals what? Sodium hydroxide plus sodium equals sodium hydroxide in drops, which is the drops, and then in excess. Now what do you observe in this situation? What do you observe in this situation? Now when you take what? A portion, the second portion of what? Of the residue, and then the what? When the second portion of what? The solution that is gotten from the second portion of the residue that is being added with dilute, and add what? Sodium hydroxide in drops to it. What do you get? You are going to get a light what? A light blue what? PPT or precipitate. You can write it into a light blue what? Precipitate, which is insoluble in excess. What? That is in drop. I'm not writing in drop. You get light blue precipitate, which is insoluble in excess what? Sodium. This is insoluble in excess aqueous sodium hydroxide. In excess aqueous sodium hydroxide. So a light blue precipitate formed. Which is insoluble in light precipitate form. A light blue precipitate form, which is insoluble. Please put formed. This is what? A light precipitate which is soluble. A light blue precipitate formed. You can put formed there. A light blue precipitate form, which is insoluble in excess sodium hydroxide. Sodium hydroxide. So what does that show? Our inference is that 2 plus, that is Ce2 plus, that is copper ion present. Now I will come again at the solution of what? 2BII plus what? Sodium hydroxide. You add what? When you add sodium equals sodium hydroxide, you are going to obtain a light blue PPT form, which is insoluble in excess what? Which is insoluble in excess sodium hydroxide. That is, you are going to add in drops first. Then when you add it in excess, you add excess sodium hydroxide, you are still going to have that light blue persisting, so it does not there's no physical reaction even when you add it in excess. So a light blue precipitate form, and when you add more to it, it retain the light blue without any physical reaction. So we have Cu2 plus what? Present. Now we have what? 2C. What does it mean? As I said, to the what? To the solution. Also to the solution in what? So you know that I have to separate what? The solution C to Z, the solution in B, still the solution of what? Of B here. So it means that this solution here, this what you have here must be divided into 2. So let me indicate. So this one now we are going to obtain a solution. We are going to obtain a solution. And to that solution, this is you add what? To that solution, you add sodium hydroxide. So sodium hydroxide, aqueous hydroxide. Now, also, that solution we are still going to add what? To that solution we are still going to add. That solution we are still going to add. Solution that you obtain from it, and this solution that you obtain from there, we are still going to add ammonium, aqueous ammonium, aqueous ammonium. We are going to add aqueous ammonium to it. So what do we have? We have solution, same solution of 2BiI octane plus what? Plus ammonium, aqueous ammonium in drops, and then in excess. And then in excess, what do we have? And then in excess, what do we have? We have what? We are going to have what? Look at this one. When you introduce ammonium into what? Into that solution. What we are going to get is a pale blue gelatinous precipitate. A pale blue gelatinous precipitate. That is, there is what? Is something like a oily stuff around what? To form a oily stuff along the inside the test tube. A pale blue gelatinous precipitate. So you put that is a pale is a more what? Deep what? A more deep what? A pale blue gelatinous what? A pale blue gelatinous PPT formed in what? In drops. Formed in drops. Now, what happened? Now, PPT dissolved in excess what? Excess aqueous ammonium to give deep blue solution, to give deep blue, to give what? Deep blue, to give deep blue solution, to give deep blue solution. So now, PPT dissolve in excess aqueous ammonium to give deep solution. We have Cu2 plus confirmed. So that's that about what we have successfully carried out this aspect. The aspect of A using testing in sodium hydroxide, and this aspect of what. So we'll continue from here as well. Okay, now we have already dealt with the residue aspect of the question. Now let's go to the feed rate. The question says, 2D says, divide the feed rate into two portions and carry out the following. Divide the feed rate into two portions and carry out the following. The first portion of the feed rate, add barium chloride, and then add dilute HCl in drops and in excess. So we have 2D here, which is the feed rate aspect. I'm talking about this aspect. Now, the question says that we should take the first portion of the feed rate, plus dilute what? Plus barium chloride, plus dilute HCl in drops, then in excess. And what do we have? Now, in drops, when you add the feed rate, this blue feed rate, when you add it inside what? When you add it into a test, when you put it inside a test tube, when you put it into a separate test, and this is the first portion of the feed rate. It says you add barium chloride, then you should add what? Then LCl, dilute HCl. What I'm going to observe is a white precipitate, formed in drops of HCl. Now, when the white precipitate formed in dilute HCl in drops, when you add BACl and add dilute HCl in drops, you have a white PPT precipitate form. the white PPT form. So what I'm going to have, these are the anions that are present in the what that are likely to be what indeed you have CO2 minus, SO3 2 minus, and what SO4 2 minus. So but when you add dilute acid, which is dilute HCl in excess, when you add it in excess, and the white precipitate persists, it does not change, there is no visible reaction. That is, when the white and you obtain white PPT insoluble, those of the white PPT insoluble in what? In excess what? The white PPT be insoluble in excess dilute HCl. In excess dilute HCl, then SO4. Notice one, these are likely to be present before in drops. But when this 5 PPT insoluble in excess, then SO4 2 minus is confirmed. SO4 2 minus is confirmed. Sulfate ion is confirmed. So this is a confirmatory test for SO4 2 minus. Then the last question says, to the second portion of the filtrate, the second portion of the add sodium hydroxide, then warm the mixture, bring a glass rod deep in concentrated what HCl close to it. This is the last question. That is, this is DI, 2DI. This is 2DII. Now, second filtrate plus what? Sodium hydroxide. That is aqueous sodium hydroxide. Then warm. That is, you heat slightly. So after that, you now have what? You now bring a glass what? So what do you do? What do you obtain before you even bring any glass rod? When you want second filtrate, now you take second filtrate, and then you add sodium hydroxide. Then you warm it. What are you likely to have? What you are going to have is that there is a gas evolved, a gas with choking what? With choking smell. The gas with choking smell was evolved. A gas with what choking smell was evolved, which turns red litmus paper to what? To blue. We turn what? Red litmus paper blue. We turn red litmus paper what? Blue. We turn red litmus paper blue. Now, this suggests it was a gas, which is an ammonium gas. An ammonium gas from ammonium ion. This suggests an ammonium gas from what? Ammonium ion. Now, so when we now add what to this what gas that is coming up, a choking gas with a gas with a choking smell that evolved that don't really much, and now bring what a glass what a glass of keep in concentrated what LC, I mean in complex here, when you bring it close to it, the gas produce dense white fumes. It produces dense white fumes with what? With concentrated what? Acid. It produces white dense. It produces a dense white fumes. A dense white fumes which will what? That white fumes will what? That gas will become white, dense and whitish. So in concentrated, then we have ammonia gas confirmed. Is a confirmatory test for ammonium gas. So the ammonium gas is confirmed. Ammonium gas confirmed. And this is the likely questions. This is the likely question that they are asked. You might meet in the upcoming exam on Tuesday rather. On Tuesday, the exam that you are likely to come across in the exam. Please remember